Hello and welcome to Live Lab number 7 on how to deploy a machine learning pipeline on AWS Lambda. So first, let me remind what is AWS Lambda. AWS Lambda is actually one of the first compute services of AWS, and that is actually serverless. So first of all, what does mean serverless? Does it mean exactly that there is no server at all? Absolutely not. Of course, there is a server. It's just that instead of creating one, like for example, creating an EC2 instance that is on for some time, well, instead of that, we're just going to have a server during the time that our function will be executed, during the time that our Python code will be executed. So it's like we have no server, then we execute the code and we have a server for just a few seconds, just the time the code is executed, and then we have no server. So that's what serverless means. Of course, there is a server, but it's just during the time that we execute our code within Lambda, whether it is a Python code or a Node.js code. All right, so that's what serverless means. And so AWS Lambda is amazing. It's really amazing. There's a lot of things you can do. And I'm super happy and proud to say that by the end of this live lab, you will become really a pro, or should I say Tony Stark in the Lambda lab of AWS Lambda, because we will touch all the different functionalities of AWS Lambda. Not only we will build a machine learning pipeline, but also we will automate it, automate a part of it. So let me actually show you this pipeline right now. That's what I prepared in the folder that I shared with you, Live Lab number 7, AWS Lambda. Here is the pipeline. You will find it in the slide folder. Let's have a look at the pipeline. So this is exactly what we're going to build today in this Live Lab number 7. All right, so the first step is we're going to load some data into S3, which will be, of course, the training data on which our machine learning model will be trained. I will introduce you to the training data in a second, but first, let's just explain the steps. So first, we load the data into S3 in one bucket that is called here bucket number 1, because there are going to be several buckets. Then next step, our Lambda function that we will build together will read the data into S3. So basically, we will connect Lambda with S3, thanks to, of course, IAM, by giving the required permissions to Lambda by giving access to S3. So it will read the data in S3 and from a certain bucket, bucket number 1. Then the Lambda function will train a machine learning model, of course, on this data that is in this bucket number 1. Then the next step, the Lambda function will save the machine learning model in a different bucket. That's why I called it bucket number 2 here. It will save it in a different bucket inside S3. And then once we have this saved model, well, we will call our Lambda function again, but you will see with a different Lambda handler to make any prediction we want. And you will see, I will explain the case study in a second. It will be to actually predict the quality of a wine. And finally, we will send some invocation records to SNS, and that's just in order to really complete this pipeline with all the functionalities that AWS Lambda offers. All right, so are you excited about that? And plus, we will completely automate this part of the pipeline, meaning that each time we update the data set, each time we provide some more data for our machine learning model, well, automatically these steps will happen, meaning that the Lambda function will automatically read the data in S3 from the bucket number 1. Then it will automatically train the machine learning model, and then it will automatically save a new model inside this bucket number 2 in S3. So that's the automated part of the pipeline. Of course, for the prediction, well, it all depends on which values we enter. So that's why I only limited the automation to these first 4 steps. But there we go. That's exactly what we're going to build in this lab number 7. So who's excited? Let me see in the chat. Are you excited to build this? Yes, so Dietrich, I will explain IAM and SNS as we progress in the lab. Okay, cool. You're all super excited to build this. Super cool. And yeah, I can tell you that by the end of this lab, you will become a pro at AWS Lambda, or, Tony Stark in the Lambda lab. So here we go. Let's get started. All right. So before we get started, I just want to introduce to you the different parts of the folder. So here you have the code, meaning the Python code that will be entered within Lambda in order to, train the model and make the predictions. Sorry about that. These are my CloudWolves, actually. And then this is the inputs that we'll enter to make the prediction of the quality of the wine. Okay, so here we go. Excuse me. I'm just going to tell my dogs to, excuse me. I'm just going to tell my dogs to make some less noise. Sorry about that. So yes, I was saying that this is the code. Let's have a quick look at the code to see the structure of the code. So I'm going to open it with Sublime Text. So it's a very simple code, with the classic structure of how to build a machine learning model. First, we import and read the CSV from S3. So that's the function doing it. Then we split the data set into the training set and the test set, because we will still evaluate our function on the test set. Then we will define a function that will prepare the data for feature extraction and target variable separation, meaning that we will separate the features, the matrix of features X and the dependent variable vector Y. Then we have this train, evaluate, save function that will at the same time train the machine learning model, which actually here is a random forest model, and then evaluate it on the test set, and then saves it in a specified S3 bucket. And then we have this final function, predict wine quality, which will predict the quality of a certain wine. And here are the inputs of the wine. And that's exactly the input we will enter in Lambda in order to make that prediction. Because I remind that actually Lambda is not only a compute service, it's actually an event-driven compute service, meaning it responds to some events. And here the event will be to indeed enter the parameters, the features of that wine so that we can predict its quality. All right, so that's the code. And now let's have a quick look at the data set. Here is the data set. So it's a classic data science data set where you have all the features in the first columns, you know, from fixed acidity, volatile acidity, citric acid, and up to pH, sulfate, and the alcohol percentage. So these are all the features of the wine. So each row, of course, corresponds to a wine, a specific wine. So that's one wine, that's another wine, that's another wine. They all have different features going from fixed acidity to alcohol. And at the end, in the last column, we have the dependent variable, meaning the variable that we want to predict, meaning the quality of the wine, which is a rating going from 0 to 10. All right, so for example, this one has a rating of 5, this one has a rating of 5, this one has a rating of 7, and this one has a rating of 6. So you see, that's exactly what we're going to build. That's the example of data set of case study in order to build this machine learning pipeline. So now here we go. Now that we understand the data and the code, let's go into AWS and start building this machine learning pipeline. So as usual, we're going to make this interactive. We're going to build this together. And therefore, I'm going to ask you some questions from time to time during the lab so that we can all build this together. All right? Any questions so far, or shall we get started? No worries about your dog. My dog is angry right now because I put her in the other room. You know, that's what I should do too. You know, if they continue to make noise, I will put them in the other room as well. That's a great idea. Chuck Woody, thank you. Yes, good luck with the man's best friend listening to the man. Yes, so that's why I muted myself. I told them to, you know, stay quiet. That's why you should get a cat. Yes, cats are indeed less noisy. I completely agree. Put them in the pipeline. Yes, I have a pipeline at home. I will put them in the pipeline. That's a great idea, Nafsika. Okay, so do you have any question before we start? Is it all clear? You know what the code is and what the data is, the case study, the pipeline? Any question on the Lambda pipeline before we start? All good to get started? Okay, all clear. Let's go. Let's do this. Super. So let's all go to the console and let's start building this pipeline. So as I said, this lab is interactive. Therefore, my first question to you is, what is the first step we should do here? I can show you again the pipeline. Where is it? It's right here. What is, according to you, the first step we should do? All right. So Nafsika says EC2. Okay. So very interesting that you're saying EC2, Nafsika. Actually, we're going to do the complete opposite of EC2. Therefore, we're not going to use EC2 at all. Let me explain why. So EC2, remember, is a compute service, but that is not serverless at all. If you use EC2, you really do have to create a server that is going to be on from the moment you create it to off at the moment you shut it down. But actually, you really have the server all this time, even when you're not executing the code. So it is the opposite of serverless. And we're doing the opposite of that. We're doing the opposite of EC2 because we're not going to create any server. We're just going to have a Python code, a Lambda function, actually. And when we execute the Lambda function, when we run the Lambda function, a Python code is going to be executed. And only during the time that this Python code is going to be executed, we're going to be provided a server. But this is just going to be during that time, that specific range of time during which the function is executed. Otherwise, we don't have any server to create, and we don't have any EC2 instance to create. So no, EC2 is definitely not a service that we will touch today. All right, so what else said? William, you're saying S3. Yes, S3 could be the first step. I usually like to start with IAM, but we can totally start with S3. I agree, that's a good idea. Priyanka also says S3. Create Lambda function, no, that's going to be a step after that. Chuck Woody says, Chuck Woody, you're already in AWS Lambda. No, let's start actually with the pipeline. Let's start with S3, okay? You see the first step here is to load the data into S3, and then will come IAM to give the required permissions to Lambda. For sure, we have to do S3 and IAM before we start building the Lambda function. So here we go. I agree with you. Let's start with S3. All right, so I'm going to go back to the console and let's go to S3. Welcome to S3. So S3 is, of course, the main storage service of AWS, simple storage service, inside which you can create different buckets that will contain data and also folders. All right, so let's do this. Actually, the data is called objects. The CSV file, for example, that we'll be importing into this bucket will actually be an object, an S3 object inside the S3 bucket. So here we go. Let's create the bucket. We click create bucket here, and let's start by giving a globally unique bucket name. All right, so let's call it. First, we're all going to call the same thing, and then we'll differentiate them with that random number at the end. So we're going to call it ML-pipeline- and here it's very important to specify what it's going to be, because we're going to create two buckets for this lab. We're going to create one bucket that will contain the data and one other bucket that will contain the saved model. And therefore, I'm calling my first one here ML-pipeline-data, because it's going to be the bucket that contains the training data, okay? So ML-pipeline-data, and then there we go, we add a dash, a random number, and let's say that it's going to be actually the reference number of this live lab, but it's mostly to make it globally unique. All right, so let's all call it like that, but with a different random number. Feel free to type whatever numbers on your keyboard, and there we go. So I'm going to actually copy this, because we're going to name the other bucket almost the same. We're just going to replace data here by model. And then we have nothing else to do. We can directly scroll down and create the bucket. And that's the bucket which will contain the data source, the data on which the machine learning model will be trained. All right, so ML pipeline data, there we go. Now let's create the other bucket for the model, meaning the bucket inside which the machine learning model will be saved. All right, so that's why I copied the previous name before. I'm going to paste that again. And what I'm simply going to do is replace data here by model. All right, model with the same reference number, which serves as, to make our bucket name globally unique. All right, and that's it. That's all we need to do. ML pipeline model with the same random number, and then we create the bucket. All right, so now we have our two S3 buckets, one for the data and one for the saved model. Perfect. Do we have any question? I'm just going to make sure that everyone follows. By the way, the super great advantage of AWS Lambda is that it's super cheap. But not only it's super cheap, but of course for us it's free because we're still in the free tier. But even if we're not in the free tier, it's like super cheap, like a few cents, because indeed we only have to use a server during the time of the execution of the code, which is therefore not much. It's going to only take a few seconds to train the model, and then just 1 second maybe to make the predictions. So that's super fast, and therefore that's going to be super tier. And that's a huge advantage of Lambda compared to EC2, of course. Okay, so Charles asked, why two buckets? So let me show you again the pipeline. As you can see, we have one bucket to load the data and one other bucket to save the model. And that's exactly why I call my two buckets ML pipeline data. So that's the one that will contain the training data. And another one, ML pipeline model. That's the one in which the model will be saved. So that's why two buckets. We need a bucket for data and another bucket for the model. Absolutely right. Napsika asks, how does the system know when to use a server? Through the triggering of the Lambda function? Absolutely, yes. Anytime the Lambda function is triggered, therefore the code being executed, then a server is provided just for the time this function is executed. Or if we run the Lambda function ourselves, well, just for the time the code will execute, we will be provided a server. And that's exactly what serverless means, but not to confuse with there is no server. Of course there is a server, it's just that we have it for the few seconds during which we execute the code. Do I generate a random number myself? Yeah, sure, you can generate it yourself. Basically, we just need to have different random numbers. So there is very low probability that you choose the same as mine because I just pushed some numbers on my keyboard. But yes, you just need to have a random number of any length you want. And that's just because we're all doing the lab together. And there are about 20 of us, right? There are 19, yes, 20 actually, 20 of us. And I recommend to start your bucket name with ML-pipeline-data for the data bucket, and then ML-pipeline-model for the model bucket. But then, just so that we can create those buckets, because they have to be globally unique, well, we have to generate a random number. What else? Why do we need two? Yes, it's because of how the code is made. So basically, in the code, well, we have one line of code that will pick the data in one bucket. But then, when we save the model, it has to be in a different bucket. It's just because of the code, basically. Napsika says, okay, thanks. My first lab spent most of the time restoring the password. Okay, are you okay now? Vladislav, are you with us? Have you created the first two buckets? All good. Okay, great. So is it all good for everyone? Can we move on to the next step? Okay, everything seems to be good for everyone, so let's do this. Let's go back to AWS. Here it is. Now we have our two buckets. And so now, according to you, well, I'm going to come back to you actually. Now, according to you, what is the next step? Exactly, upload the CSV file. So we're going to go back to S3. We're going to go into our ML pipeline data, and we're going to upload the data set that you have in the folder, the zip folder that you downloaded. So we click upload here, then we click add files, and then we go into the folder, we go into the data subfolder, and we upload the dataset wine quality red.csv. Yes, it's to predict the quality of red wines. All right, wine quality red.csv. We scroll down, we click upload, and there we go. It's uploading. It's going to take a few seconds. And close. All right. Now we have, as you can see, an object, one object, which is the CSV file itself. Basically, any elements that you upload into an S3 bucket is called an object. All right, perfect. So now we have the data into our data bucket, ML pipeline data. And now, what is the next step according to you? Nafsika, Lambda function, no, not yet. There is something very, very important that we need to do before we create the Lambda function. Yes, exactly, Jordan, you got it right. We have to create an IAM role. So I remind, IAM is the AWS service that will give permissions to either users or services to do some actions in other services. And well, actually, as you can see, Lambda, especially the Lambda function, will need to do two things with S3. It will need read access and also write access, because it will need to save the model in bucket number 2. It will need to be able to read the data in bucket number 1, therefore it will need read access, and also it will need to save the model in bucket number 2, therefore it will need write access. So we need to create an IAM role that will give to AWS Lambda, because an IAM role is actually applied to not an IAM user, but an AWS service. And therefore, we need to create an IAM role that will give to AWS Lambda the permissions of reading and writing into S3. And that's exactly what we're about to create right now. So back into AWS, we're going to open IAM in a new tab. Let's open this in a new tab, IAM, or you can enter it here in the search bar. Open link in the new tab. And there we go. We are going to create this IAM role that will give AWS Lambda the required permissions, meaning the permissions to read and write into S3. All right, so then we're going to go into roles here. By the way, I'm with my CloudWolf Live Labs AWS account. All right, so these are previous roles that were created before or roles by default. And to create a new role, we click here, Create Role. All good for everyone? By the way, at any time, because I'm trying my best to ask you the questions, is it okay for everyone from time to time, as often as I can? But if any of you needs to stop me because I'm going too fast, you can not write in the chat because I won't see it, but you can unmute yourself and say, hey, can you please stop a second? I missed this step. Okay, you just say this.
Hadlin.
Yes.
Okay.
Yes, like
you said we have to define an IAM role for the Lambda function to be able to read the data and then
yes.
to be able to write, but it's going to write a model. It's not going to write the data that it reads, isn't it?
Exactly. By writing, I mean saving the model. It will need to be able to, save a model into S3, into the S3 bucket. So it's not only read permissions that we need.
Yeah, but the model is not the data itself. I just don't understand. Logically,
yes,
I understand, but technically, it's reading a data, but it's creating a model. So the model is somewhere else.
It's creating a model, and the model will be saved in S3.
Oh, I see.
Yeah. We want to build a machine learning pipeline, and therefore we're starting from S3. The Lambda function will read into S3, then it will train a model, and then the model, okay, we will get a model, but we want to save it, for future predictions. Okay. And this model, we have two options of saving it, of where to save it. First, it can be saved in the root directory of the Lambda function, but then let's imagine that someone by mistakes deletes Lambda function, then the model will be lost. And therefore, it's better to save that model in a more safe, a safer place, which is S3. And that's why we choose to save the model in S3.
Okay, I got it. It's because the model is created from that data that it reads.
Yes, yes. We need one IAM role, but with the two permissions to read and write.
Okay. Okay.
Okay?
Thank you.
Great.
Thanks.
Sure, you're welcome. So William, you're saying no, the model we create will be stored in a separate bucket than the dataset. Absolutely correct. Thank you, William. And Neil says data will be input for the model, which will use an algorithm to make the prediction based on the previous training. Absolutely correct. Yeah, so you all understand what we're doing. This is exactly what we're doing, you see? And that's why I specified bucket number 1 here for the data, and then bucket number 2 for the model. All right? And but Nafsika, you asked the right question. You allowed me to say that the purpose of saving the model into S3 is that it's a safer place to save the model, because if we, delete the Lambda function, then the model will be lost. So yeah, thank you for asking this question. All right, so where was I? Yes, back into IAM. So did you all make sure to click create role? Is it okay for everyone? Again, you can stop me by unmuting yourself and saying stop, please slow down whenever I'm going too fast. So back into IAM, let's create that role. And of course, here we choose AWS service because we're going to create a role for AWS Lambda. And here, that's where we choose exactly which service. That's where we choose Lambda actually, and you will find it at the top just below EC2, Lambda. All right, so we're creating an IAM role for AWS Lambda. Lambda here, all good? Let's click next. All right, permissions. So which permissions are we going to give to AWS Lambda? Well, remember, we need to give read access to S3 and also write access to S3. And therefore, to make it simple, we're going to enter S3 here. And we're simply going to take the Amazon S3 full access policy, which will indeed give full access to S3 and therefore read access and write access. So we'll be able to read the data from S3 and also to save the model into S3. All right, so let's take this one, Amazon S3 full access. Then we scroll down, we click next. Then we're gonna call this role S3 full access. All right. Of course, we could create a policy that just includes the read and write access, but just to make it simpler, let's get the S3 full access policy with the name S3 full access for the role. So S3 full access, let's scroll down. This is the policy, Amazon S3 full access. And then finally, we create the role. And that was completely compulsory to do before creating the Lambda function, because you will see that when we create the Lambda function, well, we already have to specify the role. You will see that in a few seconds. All right, is it all good for everyone? Does every one of you have the S3 full access IAM role for AWS Lambda? Yes, yes, perfect. Not yet. Okay, I'm gonna wait, no worries. As I said, the purpose of these labs is so that everyone builds the applications. So I'm just gonna wait for everyone to have the IAM role. Anil, okay, you created, perfect. So you all took the S3 full access policy. Nafsika, you all good? Yes. Jordan, yes, perfect.
The service that we use is S3 or Lambda. I just got confused.
Okay.
When you create a role.
No worries. I'm going to do it again with you, and I'm not going to go up to the end so that I don't create a new one. But what you do is create role here. Then here you choose AWS service. Then here you choose AWS Lambda. You choose Lambda. Okay.
Okay.
All right. So that's because it's an IAM role for Lambda. And then S3 comes with the policy. Here, that's where you choose S3. In the search, you enter S3. And you take this one, Amazon S3 full access. It's a policy indeed that will give Lambda full access to S3.
Oh, okay, okay.
Okay. All right.
Yeah.
Then you click next. I'm going to click cancel because I already have my role. And there we go. So is it good for you, Nafsika?
Yeah, yeah.
No problem.
Perfect.
Okay, great. Super, super. So I guess everyone has the role now. And now let's move on to the next step. So what is the next step now, finally? Yes, absolutely. I love how you wrote Lambda. Absolutely. Now is the time to create the Lambda function. Basically, we have implemented this step, and now we are at this step. All right? So let's do this. Lambda, yes, time to create the Lambda function. So how we're going to do this? Okay, so I'm going to open the console in a new tab, which will be the tab for Lambda. All right, I'm actually going to put that here. All right. Lambda. Okay, so here we go. Let's enter Lambda. So it's not here. Perfect. So let's enter it in the search bar. Lambda, run code without thinking about servers. Oh, so that's actually a better, description or explanation to serverless, because indeed there is some server. It's just that we don't have to worry about them at all because they're just provided to us when we execute the code, and then they're gone. Okay, so let's go into Lambda and let's create this function. All right, so of course, when we get into Lambda, maybe you arrived in the dashboard, but you will find the functions here, and then you click create function. As simple as that. All right, then here we're going to choose author from scratch. We're not going to use any blueprint or use a container image because we're going to build our Lambda function from scratch, and we're going to give it a function name, which is going to be the same name as the one we use for our S3 bucket, but of course, we're going to replace data here by function, right? And that's the reference number, that unique number, so that we all have globally unique S3 bucket names. The Lambda function name doesn't have to be globally unique, but I'm just keeping this number for the reference, okay? So ML pipeline function. Then here for the runtime, we're going to choose, of course, okay, so here this is important. We have the option of choosing the latest version of Python, which is Python 3.11. But for a reason which I will explain to you a bit later, we're going to choose Python 3.8. And you will understand why a bit later. So let's all choose Python 3.8. Then we're going to keep the x86-64 architecture. And then there we go. That's where we absolutely need to change the default execution role. Because indeed, if you keep the default execution role here by creating a new role with basic Lambda permissions, well, you will not get enough permissions to build this machine learning pipeline, meaning you will not get the read access and the write access into S3. And that's exactly why we had to create an IAM role a priori so that we can get those required permissions to read and write into S3. All right, so here we're going to choose this option, use an existing role. And normally, if you click the drop down here, you should find this S3 full access IAM role that we just created. So let's select it. Can you all see it? Can you all select it? The perks of being Greek, because I read the perks of being geek. Yes, yes, good to go. Yes, perfect. You all have it. Great. Now let's move on to the next step. Okay, Nafsika, perfect. So we're all on the same page. That's amazing. So basically, that was the final step. We don't have to do any advanced settings here. We can directly create our function. All right, welcome to your ML pipeline function. All right, so this is the very beginning. Now, before we build the pipeline, before we move on to the next step of the pipeline, I want to show you something quite important, because as you know, AWS Lambda is one of the oldest service of AWS, and up until recently, well, it was very, very hectic and very difficult and not practical at all to actually implement a Python code, especially for machine learning. And let me show you why. Let me show you that first, the server that is going to be provided to us while we execute the code contains actually the basic Python libraries. And let me show this to you right away. Here in this Lambda function code that is provided to us by default, I'm going to try to import scikit-learn. As you can see in the code, let me open the code again in lambda function.py. As you can see, we build, of course, our random forest model, our random forest regressor with scikit-learn. And therefore, we need scikit-learn to build our machine learning model and then, of course, pipeline. Well, let me show you that actually, by default in AWS Lambda, with the server that you're going to be provided with to execute your code, there is not even scikit-learn, and you will see that there is not even NumPy either. So let me show this to you. I'm just going to enter here import sklearn. All right, then I'm going to deploy it, meaning I'm going to save the code so that when I run it, it runs exactly this code with the modification I just made. And now what we're going to do is test it here. So this is the event that you have to configure, but you have nothing to change here because anyway, the code is going to stop at the beginning, trying to import the sklearn library because that's the first line of code. As you can see, if I click test here, well, executing function failed. And why is that? That's because there is no module named scikit-learn. So as you can see, scikit-learn is not part of the libraries installed on our server. Okay, so not only we don't have scikit-learn, but I'm going to show you also that we don't even have NumPy. NumPy could be considered as an essential Python library, but you will see that we don't even have it. If I do import NumPy here and then deploy, I can even add as np. All right, deploy. Let's go back to test here. Let's test this function again, you will see that we don't even have NumPy. Executing function failed again, details, no module named NumPy, all right? So basically, in the server that is provided to you when you execute your Lambda function, any server, well, you don't have scikit-learn, you don't have NumPy, you only have the built-in Python 3.8 libraries, the essential one, the very basic ones. So that's a first challenge we need to do. It is to, integrate scikit-learn, install scikit-learn on our server, but we don't have a server. So how are we going to do it? Well, first, I want to show you the old solution, just to give us some motivation and some appreciation on the new solution that actually AWS Lambda provided recently, all right? So that old solution, I didn't provide it in the server because anyway, that's a hectic solution. That old solution, and I tried this, that old solution is actually to create a folder containing all the libraries and all the dependencies. And as you can see in the Python code, in order to build our random forest model, we need indeed scikit-learn, but we also need NumPy. And then because scikit-learn contains some dependencies, which I prepared here for you so that you can see them, here are the dependencies of scikit-learn with Python 3.8 or over. These are NumPy, SciPy, joplib, and threadpoolctl. And that's exactly why in this folder, I included all these libraries, the libraries that we need for our code, NumPy and scikit-learn, but also the dependencies of scikit-learn, which are all these libraries. Joblib, as you can see, then SciPy, then threadpoolctl, and SciPy. All right? And that's what I had to do. And how did I get those? Well, I downloaded Anaconda on Google. Then I got the whole Anaconda folder. Then inside the Anaconda folder, I went to packages. Then inside the packages, I got all my libraries, the libraries that I just showed you in the folder. For example, let me show you SciPy. All right. Well, also scikit-learn, actually. I'm going to show you SciPy and scikit-learn. You see, I had to scroll down. I had to do all these, non-practical stuff to make this work. And that's the old solution, of course. Of course, there is a much better solution. So, right, I'm in the S's. So you see, I had to find scikit-learn. Where is it? Here it is. So I had to take this, actually, inside lib. I had to take this, site packages. And this is exactly what I took. These two folders, that's exactly the packages itself that you need to enter in the folder. I did that for scikit-learn, but I also did that for SciPy just below. As you can see, I went into SciPy, then into lib, Python 3.11, site packages, and these two. So you see, it was very hectic, and that was the old solution in AWS Lambda before that new feature, which I'm going to introduce you in a second. You had to get all these packages separately from, that whole Anaconda folder, and you had to include them right here in this whole folder, which contains, of course, also the Lambda function, the Python file of the Lambda function. All right. So this was very hectic. And then once you have this folder, you just need to zip it. All right. You zip it. And then what you do in your Lambda function. So you don't have to do all this. And this is just to show you what was before in order to give us some appreciation of the new Lambda feature. And then you had to, well, first, you had to upload it, but you can't really upload it from a zip file because you will see that the zip folder is too big. Indeed, if I try to, upload that zip folder, no, it's not this one. Actually, let me compress it. Let me actually create that zip folder. Here we go. It's going to take a few seconds. So that's what you have to do. You have to create this folder with all the packages and libraries that are needed to execute your code. Then include your code. Then compress this folder into a zip folder. And then you will see that you can't directly upload this folder. As you can see, if I try to upload this folder, I will get an error because, as you can see, the selected file is too large. The maximum size is 50 megabytes. So what I have to do is actually upload it from Amazon S3. And with Amazon S3, you can upload larger files. So let me show you right away. If I go back to Amazon S3, and if I put, for example, if I upload this zip folder in the S3 bucket, so which one is it? Yes, this one, Lambda function zip folder containing the code plus all the libraries that are needed for the code plus all the dependencies of scikit-learn. You click upload. It's uploading. It's going to take a few seconds now. No worry, it's not going to take 60 minutes, just a few seconds. And you will see this was the old way of actually building a machine learning model in AWS Lambda. And that was absolutely hectic, as you can see, with all the things that I have to do now and that I did before. We didn't even download Anaconda and everything. All right, so Now we have this zip folder into my ML pipeline data bucket. And so now back into my Lambda function, you do this, upload from Amazon S3 location. Here you have to enter the Amazon S3 link URL of that exact zip folder. So back into it, I'm selecting it, copying the URL, and then back into my Lambda function, I'm pasting the URL here, and then clicking save. And there we go. That was the old way of, having in AWS Lambda the possibility to build a machine learning model with scikit-learn and NumPy. All right. So now this is the core source. We have our code, and we can execute the code and start building the pipeline. But of course, this is not what we're going to do. I just wanted to show you this so that you can see how so much better is the new way, the new artifact that AWS Lambda created recently. I think it was 2 years ago. They created a new artifact allowing us to import much more easily, libraries that we need to execute our code, especially here our machine learning code, scikit-learn. And so let me show this to you. But first, because we have this now, I have to create that function again. I'll do it super quickly. So I'm just going to first delete it. All right, delete. Don't worry, you don't have to do these steps. It was just to show you. Now I'm going to create the same function, the exact same one, super quickly with the same name. Here I'm going to enter Python 3.8 with the same architecture, the same S3 full access role that we created, S3 full access. All right, and create the function. All right, so now we're back together. Now we're back implementing all the steps of the pipeline, of building the pipeline together. Because indeed, that much better solution that AWS Lambda brought in recently to import some libraries that are needed for our code is an artifact of AWS Lambda called layers. That's exactly this. The layers are the new solution to import a library. Because indeed, you will see that we will import scikit-learn and NumPy in just one click, 1, 2, or 3 clicks. You will see it's super fast and simple. Let's all click layers here, and this will take us to the bottom of the function page. So here in the layers, you're going to click add a layer. All right. You're going to choose here, not AWS layers, not custom layers, but specify an ARN. And then indeed, on GitHub, you can find plenty of ARNs, which contains, packages, libraries. You will find some ARNs leading to layers containing scikit-learn. You will find ARNs leading to layers containing pandas. You will find layers containing NumPy. Everything you want, you will find on GitHub. And that's exactly why I prepared this GitHub repo here, who we are crediting with a lot of thanks. Here is a GitHub repo containing a Lambda layer that has scikit-learn and all the dependencies, therefore NumPy as well. And so the only thing we need to do here is get the latest scikit-learn version for Python 3.8. And you will see that if I scroll down here, it will stop indeed at Python 3.8. The higher version of Python that we find is Python 3.8. So make sure to select Python 3.8 here, then make sure to choose US East 1, and then the latest version of scikit-learn that is provided here as a layer, which is this one. So now what I'm going to do, I'm going to copy this link. I'm going to provide it in the chat. Yes, crazy stuff, Natsika. I completely agree. This is the link of the GitHub repo containing all the layers, and you will see that with just one click, we will be able to import scikit-learn and all the dependencies, including, of course, NumPy. So yeah, huge kudos to Model Zoo for providing these layers, because now we just have to indeed get the ARN of the latest version contained here in this repo, which is 0.23.1, for Python 3.8, which is exactly why we had to choose Python 3.8 and not Python 3.11, but I'm sure that in time we will find some Lambda layers containing scikit-learn for Python 3.11 and for US East 1. Well, make sure you are in US East 1. I suppose all of you are in US East 1, but indeed the reason why I'm choosing US East 1 is because here I'm in US East 1 North Virginia, right? If you are in a different region, of course you choose the ARN for that different region, all right? So let's do this. Let's take this. That's exactly what we need to take, the ARN here, containing scikit-learn and all the dependencies, therefore NumPy as well. So let's copy it. And then back into Lambda, you will see how so simple it is. Specify an ARN. We paste that here. Let's verify it to check that all is good. Yes, perfect. Verification passed. And then, as I told you, with one simple click, we click add here. And now you will see that we will have scikit-learn and NumPy within AWS Lambda, with AWS Lambda function, which means that when we execute the code, well, on the server that will be called just the time, just a few seconds during which the code will be executed, well, the NumPy and the scikit-learn libraries will be available to us. And I'm going to show this to you right away. We're going to do that test again. We're going to start, let's start with the simple test, scikit-learn, import sklearn. All right, let's not forget to deploy to save the code. Excellent, import sklearn. All right, updating the function. And now let's test it and let's see if it works. Let's see if we're going to get that module import error. I have to configure the test first. All right, so this is the event. We don't have to change anything in the event. We just want to test the code. So let's click test from here. 3, 2, 1, go. Test. Executing function. As you can see, there is no error. The function is executing properly. Indeed, we will have scikit-learn now. That's the function. And see if we execute it from the code also, you will see. All right, this is the response, hello from Lambda. So this is a simple hello world kind of code, but for Lambda, so hello from Lambda. And as you can see, the code executed properly, even though we had import scikit-learn at the beginning. And same for NumPy. I will show you that we also have NumPy with absolutely no issue when we get that server just for the few seconds we execute the code. Let's deploy this again. Let's updating the function, successfully updated. Let's go back into the test. Let's take test here, executing function, started and succeeded. We also have NumPy, no problem, you see? So now we do have NumPy. Yes?
Hadlin, when I do deploy and then test, it asks me to create the test event. I didn't catch that.
Yes.
So we say create new event private or shareable?
No.
We leave private and then...
No. So you can cancel that. Actually, the very simple thing to do, because I got the same thing, is just to go to test. Instead of testing your function from the code here, you go to test and then you click test. Because if you execute it from the code here, it will indeed ask you to create an event, because I remind that a Lambda function runs based on an event that is provided. It's an event-driven function. So yes, that's exactly why when you click test from the code here, it will ask you to create an event. So go to test here, the test tab, and click test after, of course, deploying your function. All right, so let's see your comments. I guess you're pretty excited by this new solution, this new artifact that AWS Lambda provided, which are, of course, the layers, Lambda layers. Really cool, merci beaucoup. You're welcome, most welcome. Kudos, Model Zoo, yes, absolutely. And Diane, you're asking, so you still need to upload it from somewhere externally, but it's easier to find the libraries online so you can use the layers. Yes, basically, you're right. You're absolutely right. We can also upload it from somewhere externally, but thanks to this ARN, yes, you can just find it online. I actually found many other ARNs of many other libraries for Python. In our case, we need scikit-learn and NumPy, so I got the ones for scikit-learn, which also contains the NumPy because it's a dependency of scikit-learn. Okay, most welcome, Hector. I'm super glad that you find it cool. Indeed, this is super cool. This is so much simpler. Now with just one ARN, we're able to have scikit-learn and NumPy to build our machinery models. All right. Yes, Brian, you're right. I just saw this. There are lots, especially with stuff like TensorFlow XGBoost. Absolutely. You will also find ARNs to import the XGBoost library, because I remind that XGBoost is not part of scikit-learn, but you will also find some ARN containing Lambda layers that have the XGBoost library. All right, cool. So great. Now we have scikit-learn and NumPy, so we're ready to build our Lambda function. Okay, so let's do this. Any question before I move on to the next step? Okay, excellent. So let's do this. So now what we're going to do, now that we're convinced that we have scikit-learn and NumPy, what we're going to simply do is go back to our folder, and inside our LiveLab number 7 folder, we're going to get into our code, lambda function.py. We're going to open that with Sublime Text, or any text editor, sorry. We're going to open that with any text editor. We're going to select the whole code, copy it, and back into our Lambda function, we're going to select everything here, delete, and paste it. And of course, then we're going to deploy it. Because that's exactly the Python code that will run, the heart of the pipeline. Meaning that will not only read the data into S3 from bucket number 1, the data bucket, but also train the machine learning model on that data in S3, and then saving the machine learning model in that other bucket in S3. and then it will make later on the predictions. But for this, we will have to enter an input. It will not be part of the automated pipeline. All right, so did you all paste the whole code in your Lambda function and deploy it? All good here. Diane, all good for you. Nafsika, no? Okay, no worries. I'll wait until everyone is ready. Jordan, yes, perfect. Excellent. Chuck Woody, yes, ready, perfect. Nafsika, yes, great. Hector, are you all good? Did you paste the code and deploy the function? All good, perfect. So let's continue. All right, so now that we have scikit-learn, now that we have the Python code that is the heart of our Lambda function and therefore our machine learning pipeline, what do we have to do? Well, you can't really guess unless you know Lambda. But as you can see in the code, there are several functions. There's the function that reads the CSV file. There's a function that splits the data, function that separates the features and the output, the dependent variable, a function that trains the model on the training set, evaluates it on the test set, and saves it in the specified S3 bucket, and another function that predicts the quality of a certain wine, of which we will enter the features in Lambda. So as you can see, there are several functions, and therefore we need to know, the next time we run the Lambda function, which of these functions will be executed. And this specific function that we have to choose to be executed when we run the Lambda function is called a Lambda handler. And that's exactly why below the code you will find, well, first you find the code properties, but just below you will find here handler. And that's very, very important in AWS Lambda, to understand the handler. It's basically the function within your code, within your Python file, which will be executed when you run the Lambda function, okay? And therefore, here we have to edit this. So here, just make sure to understand that Lambda function here is exactly the name of the Python file. So in other words, if my Python file here had another name, if for example it was called randomforest.py, well here we would need to enter random forest, not .py, just random forest, the name of the Lambda function basically. And then here, Lambda handler is the function within your Python file that will be executed when we run the Lambda function. And therefore, the first thing we're going to do in order to proceed to the next step here, which is to train the machine learning model after reading it, well, is to enter this for the Lambda handler. So let's all take the name of that function, train, evaluate, save. Let's all copy this. And then just below, in runtime settings, we're going to click edit here to put the right name of the Lambda handler. We're going to replace Lambda handler here by exactly the name of that function which we want to execute, train, evaluate, save. Now, some of you might be thinking, so why don't we take that other function that reads the data into S3, as the Lambda handler? Well, we could totally do that as well. In that case, we would, the machine learning, the Lambda function would only read the data into S3. But since this Lambda handler that we just chose here, meaning the train, evaluate, save function, actually already integrate the function that reads the data, well, we can directly move on to that handler, train, evaluate, save. Because anyway, what we want at the end of the day is to have a trained model. So we will directly use train, evaluate, save as the Lambda handler, so that we can not only read the data into S3, but then also train the model, evaluate it, and save it into S3 at the same time. So we directly pick that handler, train, evaluate, save, and that's all we need to do in these runtime settings. All right. So make sure to keep the same name here for the Lambda function, because that's exactly the name of our Python file, unless you changed it. And then for the first Lambda handler, we pick here train, evaluate, save. All right. And then we just have to scroll down. We already have our scikit-learn layer. All is good here. So we just click save. And there you go. Now we have the right Lambda handler. Okay? So we're making good progress here. Is it all good for everyone? So, Diane, okay, so we have two questions. Anil, you're asking, for production deployment, you will train plus save the model and then call it, looking at a S3 bucket formula from future execution of the function without the need to save it again and again. Is that correct? Yes. So that part we will implement right after. So far, we're just building the pipeline and testing it manually, but then we will implement that automation part of the pipeline so that we don't have to do anything. We don't have to click, change the handler and click the test button, execute the code, save them all. You will see that this will all be automated at the end of the lab. Diane, you're asking, so we can use the same Lambda with different handlers? Yes, absolutely. You have two options here. Either you create two Lambda functions, each having its own handler, one handler, or you can create one Lambda function with different handlers. That works completely fine. The reason why it's fine that we're going to use two different handlers in one same Lambda function is because the other handler that we're going to use to make the predictions is not part of the automation. So it's okay that we have the same handler in the same Lambda function. It will be more practical for us, actually, when we want to make some predictions. Nafsika, you're asking, the handler was given that name as that function calls all the other function. The handler was given that name as that function calls all the other functions?
Yeah, it's not clear, but when you give that name for the handler, it means that it will just execute that function.
Exactly. Yes. When I gave that name,
sometimes inside the function you call other functions in Python. Well, you don't call other functions, but some results in the functions are obtained using other functions. I don't know if you get what I mean. No, you don't. Because that handler will only execute that part of the code, not the other parts.
Okay. So basically, in a Lambda function, you have to provide several functions, each of which can be a handler.
Oh,
okay. And exactly. And in this Lambda function, depending on what you do with this Lambda function in your machine learning pipeline, you have to choose a specific function among all the functions of your Lambda function. And when I say it's among all the Python functions of your Lambda function. So yeah, I know it can be a bit confusing, but basically you have a Lambda function, which is a Python file containing many Python functions. And because it contains many Python functions, well, when you run the Lambda function, you have to specify which Python function you want to be executed. And that is thanks to the Lambda handler.
Oh, so that means that if you want to execute all the functions, you need an individual Lambda function for each, an individual handler for each Lambda function.
Exactly, yes. But if you want to execute all the functions, and that's actually part of what we're doing, if you want to execute all the functions, what you have to do is make a final function that calls all the previous functions in your Lambda function, and then enter as the Lambda handler that final function, so that everything is executed. And that's a bit what we do here. Well, we do part of it, but basically, look at the code again. In the code, as you can see, the Lambda handler that we just chose is this one: train, evaluate, save. But actually, this Python function calls all the previous functions we built before. It calls the prepare data function. It calls the split data function.
That's what I meant. That's what I meant.
Yes. Okay. So yes, what you're asking is yes, you can do that. And in order to that, you have to integrate the other functions in your handler function. I get it. Okay. Yeah. All right. Perfect. But basically, by entering this Lambda handler, train, evaluate, save, all these previous functions will be executed to read the CSV, to split the data, and to prepare the data, but not the final one to predict the wine quality, which makes sense, right? Because at this point, we only want to save the model, to train the model and save it. All right?
Okay. Yeah.
Okay, we had another. Thanks. You're welcome. So we had another question from Zihan. I'm getting an error message while pasting the code. Failed to update the function ML pipeline function. That's strange. Uploaded file must be no. You must not upload any file, Sihan. That was the old solution that I just wanted to show you to appreciate how the new solution by Lambda, which are the layers artifacts, are much better. But you should not do this. For that new solution, you should not do upload from. This was for the old solution. The only thing that you have to do is get into the folder that you downloaded from the event, then open this Lambda function Python file in a text editor. You select the whole code, you copy it, and then inside the text editor here, you paste it. That's all you need to do. The other solution was just to show you how so much better and so much easier it is to now build a machine learning model and pipeline within Lambda. I mean while deploying. You mean while deploying? Yes, I've done. Okay, you've done the copy paste. So you mean okay. So you've done the copy paste, you deployed your function and you're getting an error. What is the error? Fail to update the function. Okay, that's strange. Fail to update. Okay. What could be the problem? Because I don't understand why it says uploaded file must be a non-empty zip. That's strange. I suggest that, because I never got this before, so I suggest that you delete the function, you create a new one, and we will wait for you to do that because it's very fast anyway. You delete the function, you create a new one, then you import the layer. You create a Lambda layer with that link I provided before. Done that as well, and you're still getting the error. Yes, did you take Python 3.8? Yes, okay, that's very strange. Okay. So what could be the issue? Okay, what I'm gonna do is I'm gonna redo the steps with you, and we're gonna make sure that you selected exactly the same things. So here you clicked create function, then you give your function name, then here you chose, of course, Python 3.8. Then here, did you choose that architecture, x86-64? So make sure to choose that architecture, then change default execution rule. Here, did you make sure to choose an existing rule and then the S3 full access rule that we created before? Then you clicked create function. Now I'm going to go back to my function. And then inside that, what did we do first? Do not do any upload from here. That was just the old solution I wanted to show you. So do not do any of this. So then the only thing you had to do was to go to layers, then add a layer, then click specify an ARN, enter this, the ARN, and then click add. And that's all you needed to do. And then in the code, you just had to paste this whole code and then deploy. And you're telling that you're having an issue? Okay. Sihan, I'm sorry, I don't have any troubleshooting idea right now because this never happened. But definitely after this lab, I'll help you debug that, okay? We will work together and I will debug that for you because at this point right now, I'm not sure what could be the issue of that. No problem, I'll follow. Yes, please follow and no worries, there'll be the recording. And besides, after the lab, I will help you. All right? Great. All right, so now let's continue. Let's go back to Lambda. We were there. So what did we just do? Yes, we provided the right Lambda handler, train, evaluate, save. Okay, that's very important. We have our scikit-learn layer. That's absolutely awesome, so that we can indeed import scikit-learn and NumPy. And now what is the next step? Well, we have some configuration to do. Let's go to configuration and let's configure what we have to configure. So first, we indeed have to configure some stuff in general configuration here. Because indeed, as you can see, the default timeout, meaning the limited duration during which you can execute your code is 3 seconds. But actually, 3 seconds won't be enough for us to train our random forest model. We actually are building, let me show you the random model forest again. Let's have a look at the model itself. It's with scikit-learn. It's very simple. Here it is. So we basically build an object of the random forest regressor class with 100 estimators, 100 trees. So there are going to be a lot of computations, and therefore it's definitely going to take more than 3 seconds to train our random forest model on our data set. Let's have a look at the data set again. Let's see how many observations it gets, meaning how many wines it has in the data set. It has 1,600 wines. So it's actually very small, but even that, because we have 100 estimators, it will actually take more than 3 seconds to train the model. So first we have to increase the timeout. So we're going to click edit here, and we're going to increase that to 59 seconds. It will take much less than 59 seconds to train the model, but just to get some margin and just to make sure the code can execute properly, Well, let's choose 59 seconds here. And then for the memory and ephemeral storage, it is fine. This is much more than we will need. This is much more than we will need, so all good. We just have to increase the timeout, and let's increase that to 59 seconds. That's the first thing we need to do. And of course, we have the S3 full access role. So we click save here, and great. Now we have the general configuration all set for the timeout. Now, there's a lot more configuration that we can do here, but we only have one thing to configure. Can anybody of you, this is a difficult question, but can anybody of you guess what we have to configure here in this configuration? Function URL? Function URL? No, this is not it. Almost, William. This is not that, but this is something similar. Destination. Destinations. Let's have a look at destinations. So yes and no. We will actually create some destinations, but that's for the final part of the pipeline. This will be to send the invocation request to SNS. But right now, at this point, we just need to implement this step, meaning we will run the code to train the model and save it into S3. So no, it's not yet destination that I had in mind. So what, according to you, is it? Trigger. Great. So trigger is another great idea, which we will do at some point in the lab, but that will be for the automation, to make that automated pipeline. So not yet. What do we need now exactly? Permissions. No, William, we already have all the permissions that we need, thanks to this IAM role. Oh yeah, Jordan, you said it. Sorry, I didn't see it. Jordan provided the correct answer. Congrats. Indeed, what we have to update now is the environment variables, and let me explain why right away. So let's go back to our code. And as you know, right now, we all have the same code, okay? We all have the same code here. We all pasted the same code in our Lambda function. However, we all have different bucket names. We all have different bucket names for the data bucket and bucket name for the model bucket. And not only that, we all have different URL for the wine quality red CSV file. And therefore, we indeed need to create some environment variables in order to make this code work for everyone. And that's exactly why we have this first code section here, defining the environment variables, so that we can all provide the correct unique URL that each of us has, and for the data in this S3 bucket, and also the unique bucket name that will contain the saved model that each of us has. All right, and that's exactly the purpose of these environment variables in order to make the code work for everyone here. Okay, so let's do this. Let's define, let's enter the environment variables. That's going to be with a key and with a value. So let's go back to configuration, function, the environment variables. Let's click edit, and let's click add environment variable. So according to you, let's first create the environment variable for the S3 data URL. According to you, what do we need to input here for the key? Name of the variable. Exactly. That's exactly right. Name of the variable, which is indeed data S3 URL. All right. That's the name of the variable, the name of the environment variable in our code, in that same code that we have. So indeed, that's the same key that we're going to enter. Every one of us is going to enter the same here, data S3 URL, which is the name of the environment variable in the code. But now for the value, what, according to you, do we need to enter? And here we will have to enter all a different value, which is, of course, the URL. And therefore, the URL of the CSV file. And therefore, I'm going to go back to S3. And there you go. We have two options. We have two ways of getting that URL, either by selecting, well, no, this is something that I have to delete. This was just to show you the previous thing. Let me just delete that quickly so that we don't confuse anything. Permanently delete objects. All right, so I was saying we need to get the URL of our CSV file. So we have two ways of getting it. First, by selecting the CSV file and then click copy URL. All right, and the second way, you enter the object, wine quality red CSV, and then you get the object URL right here. This is the exact same URL, and this is a URL you have to provide as the value of your environment variable, because that's exactly what data S3 URL is supposed to be, the value of that environment variable. All right, let's all get this S3 object URL. It's basically the URL of your S3 object, which is the CSV file itself. Let's all get this, and then let's click Save. All right, excellent, perfect. So now we have our first environment variable, but then we also need another environment variable, because indeed we will need to save the trained machine learning model in our S3 bucket, and we all have different S3 bucket names, right? We all have a different name for the bucket containing the saved model, and therefore for the second environment variable, we need to do exactly the same. Well, let me get the environment variable in the code. This is model bucket name. This will be the environment variable of containing the name of the bucket in which will be saved the model. So back into configuration, let's click edit here again. Let's click again add environment variable. Let's enter model bucket name, which is the name of the environment variable in the code that we all have as the key. And then in the value, of course, what are we going to enter? Well, of course, we're going to enter exactly the name of our S3 bucket we created to save the model. So I'm copying this, and then back into environment variables, I'm pasting it for the value. And there we go. Now by clicking save with these two environment variables created, now we all have the same code, thanks to these two environment variables. Now this code can work for all of us, even though we have different S3 bucket names and different S3 object URLs. All right, pretty cool, no? Let me go back to the chat. Yes, key model bucket name, perfect. Exactly, that was the key for the second environment variable. Exactly right. So this is the dog that has been in my legs since the beginning of the lab. It's an Alaskan Malamute from Alaska. All right, which is why I like to call them CloudWolves as well. Okay, so all is good for everyone. Did everyone create the two environment variables? Is it all good for everyone? And then you can test that in the code, actually. Back in the code, you can check that you have indeed your environment variables by going here to environment variables. And then for Mac users, you're going to press Command, Shift, and E. And for Windows users, you're going to press Control, Shift, and E. So I'm on a Mac, so I'm going to do Command, Shift, E. And as you can see, we have our two environment variables. Perfect. Very good. Very good. How do you get, okay, so we have some questions here. Second environment, not ready. Okay, sure, no worries, Nafsika, we will wait for you. Chuck Woody, you're asking, how do you get the URL for the second bucket? No. For the second bucket, it's not the URL that you need, it's just the name. You just need to provide the name of that bucket in which will be trained the model. And therefore, what I simply did is just, I went to buckets in Amazon S3, and then I just copied the name of the model bucket. ML pipeline model with your random number, you just copy it, and that's exactly the value of your second environment variable, meaning the value of that environment variable, model bucket name. All right? Sorry about that. Okay. So yes, back in the chat. Okay, done, great. Okay, all good, Chuck. Did you get the name of the second bucket? Yes. Okay. Perfect. Diane, you're asking. So the first. Sorry. Let me talk to my wolf dogs. Yeah, they're done. Okay. So you have a URL. Excuse me, just a second. Sorry about that. So Chakwudi, you're saying you have a URL for the first S3 data. Yes, correct. For the data, you need a URL, but for the bucket, you need just the name. Yes, you have, okay, so all good. So Diane, you're asking, so the first environment variable is a file and the second a bucket. Yes, correct. Basically, the first environment variable value is the URL of that object being the CSV file, and the second environment variable is the name of the bucket in which will be trained the model. Thank you. Okay, all good, Diane? If you want, I'll show you. I'll just show you the two environment variables again. Here they are. As you can see, for data S3 URL, it's the URL of the object being the CSV file. And then for model bucket name, it's the name of the bucket in which will be trained the model, meaning ML pipeline model. All right. All right, all right. All good for everyone? Yes, got it, thanks. Okay, perfect. Perfect, perfect. Let's continue. Okay, so back into the code, we have our environment variables, we have our scikit-learn layer, we have our Lambda layer containing scikit-learn and NumPy, we have the correct Lambda handler. So my friends, we are ready to actually run the Lambda function. First, we're going to do it manually, and then we'll implement the automation at the end. So let me show you. How can I show you this? So first, we need to do something very important in test, because it's not going to respond to any event, except us pressing the test button. Here, we're not going to have any inputs. We're not doing the predictions yet, so we just want to train our model, and therefore there's not any inputs that we have to provide in an event. And therefore, we're going to provide a non-event, a null event. And you just need to remove all the three keys here, leave it like that, null event, and then that's it. You need to do that in the test, otherwise it will think that it's responding to an event containing some inputs. So make sure to enter none here, and now we're good. Now we're going to go back to the code, and so let's have a final look at our handler, just to see what it's going to do. I remind that first it's going to train a random forest model on the training set, which is the result of the splitting of the data set into a training set and a test set. Then it's going to evaluate it in the test set here. And as you can see, we'll get the mean absolute error on the test set, which is actually 10% of the whole data set. All right. And then it will save the model in a specified S3 bucket, meaning the S3 bucket we created for the model. So let's all check that indeed inside our model bucket, we have no object, but you will see that once we execute our Lambda function here with the right Lambda handler being train, evaluate, save, well, you will see that a model will be saved once it is trained. So are you ready? Let's do this. We just have to click. Make sure that you entered a non-event here, null event. Make sure that you did this. You just have the brackets here. And once done, you're completely ready to first manually, then we will automate the pipeline, but first manually test the model. So let's do this. 3, 2, 1, go. Test, loading, execution started. We have scikit-learn, we have NumPy well imported, perfect. 5 seconds, 6 seconds. Now the random forest model is being trained on the training set. And in a second, we will have the result, the execution result. And actually, I will immediately then go into the bucket. So there you go, random forest model 96. Okay, perfect. Now let's go into the model bucket. Let's refresh here. And there we go. We have the saved model, random forest model 96. Now, why 96? That's because we're going to create several models in this lab. And so I just added a random number generated so that we can distinguish the different models that will be created. So you probably got a different number than 96. This is completely fine. It's just in order to distinguish the future random forest models that will be created. So congratulations, did you all get a random forest model? My machine is fast. It's not my machine, actually. It's the server that is provided to us. You should get more or less the same duration. All right, so, okay, Nafsika, you got an error. And Shakwudi, no, not yet. By no, do you mean that you didn't get the results yet? Okay, so Chakwudi, handler, train, evaluate, save, missing on module Lambda function. Okay, so did you make sure to provide the Lambda handler? Chuck Woody, did you, in Lambda, did you click edit here in runtime settings, and do you have exactly this? This is exactly what you should have in your handler. I'm gonna paste it in the chat. And this is exactly what you should have. You have this? You got an error, okay. Yeah, so it's really a handler issue. Chuck Woody, you seem to have a handler issue. Can you please take a screenshot and show me your runtime settings? I just need to check this. And also, did you make sure to deploy your function? And Nafsika, did it work for you? And Diane, did it work for you?
Maybe I didn't deploy, so I'll go and deploy. I think that's the problem.
Okay, no problem. Is it all good for everyone? Were you able to not only execute the function properly, but also get the saved model in your model bucket? Ah, Chuck Woody, you forgot to deploy. Okay, so that was the problem. Okay. Yeah, makes sense. It was either the handler or the deploy. Jordan, perfect. Yes, it works. Great. Awesome. Danielle, all good here. Perfect. Perfect. So far this is William, good to go. Great. Awesome. Thank you for letting me know. This is great. And so far this is only the manual step. There's no automation of the pipeline yet. This will be brought thanks to the triggers of Lambda, which is also a recent artifact. Nafsika, you're still getting an error. Okay, so what could it be? Can you show me a screenshot of the error you're getting? Model bucket name. Okay, so there must be a problem with the key and value that you entered for this environment variable being the model bucket name. Can you show me what you have in your environment variables? Yes, you got it, Chuck Woody. Great, amazing. And you got random forest model number 93. Close to mine, actually. I got 96, no? Yeah, you got 93. Perfect. Great. Yes. Okay. William. Ah, you got it. Great. Random forest number 45 for William. So the reason why we all have different numbers is because we're going to have several random forest model. And so you have just a number between 1 and 100 that is randomly generated when you train a model and when you save it. So that then when we create different models, we can distinguish them. We could also distinguish them with the date and time created, but I thought it was easier with the number. Okay. So yeah, Nafsika, I think the issue might be related to the environment variables. Let me show you actually where that number is randomly generated. It's actually here, you see? That's the beginning of the name of your model, random forest model, and then we generate a random number between 0 and 100 so that by the end of this lab, when we have several random forest models, we can distinguish them easily. Unless we pick twice the same randomly generated number, which has changed to happen, but little. 1 out of 100 if we create two models. All right, so William, test. Sorry, what is that, William? Tools? Show environment variables. Yeah, so you can select tools and show environments if you have issue. Yes, Nafsika, William is right. One way to show the environment variables is to go to tools, indeed, or you go to the environment variables tab and then you press Command Shift E, and you have your two environment variables. So I guess the issue has to be, yeah, great, you shared that. All right, so your data S3 URL seems to be correct, yes. And your model bucket variable name seems to be correct as well. You named this 1, 2, 3, 4, 5, right? ML pipeline, model 1, 2, 3, 4, 5. Does anyone see some issue or problem with the way Nafsika created her environment variables with the key and the value? It seems to be correct, right? I don't see any. But there's. Yeah, no, it seems to be correct. Bucket name has 6 missing. Okay. So you have a 6 in your bucket name. Yes. Thank you, Anil. Absolutely correct. I didn't see the 6 here. Yes. So you see, Nafsika, your bucket name is 1, 2, 3, 4, 5, 6. It's not 1, 2, 3, 4, 5. So Anil is absolutely right. You forgot the 6 in your model bucket variable name. Thank you. Thank you so much, Anil. You see, that's exactly how I love working together. We help each other building this machine learning pipeline. Great, awesome. So Nafsika, we'll just wait for your code to work now. It should work because this seems to be only the issue. And once you have your saved model, let us know. And in the meantime, we can take a little break, or I'll just stay here. I have my dogs around anyway. But should you have a file? Yes, Chakudi, you should have a file saved. I mean, you should have a model save in your object. Are you in the right bucket? Refresh, Chakudi, refresh. Click the refresh button here. You have to click the refresh button and you should be able to see your model. Nafsika, how to modify the name. Okay, let me show you, Nafsika. Let me show you exactly what you have to do. So you go back to configuration, the configuration tab here. You go to environment variables, then you click edit, and then for the value of your model bucket name here, you just add a 6. Just add a 6 at the end, and that's it. That's all you need to do. You add a 6 at the end, and you click save. All good, Nafsika? Okay, check with you. You can see the model. Perfect. You can see the saved model. Nafsika, were you able to follow? It's running. Great. Perfect. Awesome. Congrats, Nafsika, for troubleshooting this issue. And thank you, Anil, again, for noticing the 6. I'll be right back. I'll just going to fill this again with some water. All right, Nafsika. So it's running. I suppose it's executed successfully now. No, still bucket name. There's still some issue with your bucket name, really? Did you deploy? No, you don't have to deploy the code after modifying the environment variables. You didn't change at all the code, right? The code doesn't need to be changed at all. There's nothing to change in the code. You just have to create the right environment variables with the right bucket name for your S3 model bucket. Okay, let's take a little break while Nafsika is troubleshooting. I'm going to stay with Nafsika here to fix her issue. No, you didn't change the code. Good. Let me go and check the names. Yes, and if you want, please show us a screenshot of your environment variables. And in the meantime, if any of you has a question, feel free to shoot. All right, let's have a look at your... yes. ML pipeline model 1, 2, 3, 4, 5, 6. Okay, now can you show me a screenshot of your S3 buckets? You just show me a screenshot of your S3 buckets in S3, not within the bucket. Show me the 2 buckets. Show me the 2 buckets in S3. Okay, I get it. Okay, so basically, you called your ML pipeline data with 1, 2, 3, 4, 5, 6, and your ML pipeline model bucket with only 1, 2, 3, 4, 5. So actually, you did have to remove the 6. So yes, remove the 6 because I thought you kept the same unique reference number for both buckets, but actually you removed the 6 for ML pipeline models. So in your environment variable for the model name, the model bucket name, it has to be this. You just copy this ML pipeline model 1, 2, 3, 4, 5, and you paste it. Paste it in your environment variable.
Now I can't remember anymore whether environmental
Okay,
variable.
no worries. Let me
Can't
show you. Let me
remember.
show you. So back
Yeah.
in Lambda, you go to configuration, then you go to environment
Okay.
variables. Okay, configuration, environment variables.
Oh,
Then
okay.
you click,
Okay. Yes.
yeah.
No,
Then you
I
click
did
edit.
that. I did that. I corrected that.
You corrected that, but
I did it already. Yes, yes.
in model bucket name, you don't have the 6 at the end here, right?
No, I don't. That's why I didn't.
You
I
have
tried.
5 also, right?
Yes, yes, yes.
Okay, okay. Now go back to the code and also Nafsika in test. Just make sure you have this. You have those brackets only, right? With no
Yes.
inputs. Just double
Yes, I
check.
did. Yes, no input. Do I have to save
Okay.
something? No.
No, no, no,
Oh, I
nothing.
didn't save. I didn't save test event. I should have saved.
No, 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 no. You
Right?
don't even have to save the test event. No, 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 no.
Okay. So I did that.
Save is
It's
just to create an
empty.
event. Okay.
Oh,
It's empty, but with the brackets, there are the brackets, right?
yes, yes. Open, close.
Okay. Okay. And then you click test in the code source.
I do it again. Wait. Okay. It's running.
Okay, so it's a good sign that it's running that long now. I think you should get it.
Just a few seconds now. 25.
Yeah, it should be okay.
No, I don't know
I know.
why. It says
Okay.
unsafe test event.
So Nafsika, no worries. We will troubleshoot this together right after the lab. But just for the others,
Okay.
let's continue,
Yes.
okay? But no worries. I will debug the issue after the lab, along
Okay. Thank you.
with the other issue. Okay. Okay.
Thanks.
So no worries. No worries. I'm here to help. I'm here so that everyone manages to build this pipeline, whether it is during the lab or after the lab. Okay. So is everyone done with the break? Is everyone back on track? And is everyone ready to move on to the next step? I'm just going to wait for a few yeses in the chat, just to make sure that everyone got back from the break or is back here. Eric, yes, perfect. Daniel, yes, great. Chakudi, yes. Vikas, yes. Everyone is here, perfect. William, are you here? Okay, so let's do this. Yes, good to go, perfect. Let's do this. Let's go back. All right, so now we have a saved model in our ML pipeline model bucket. Great, random forest. And so now we're going to move on to the next part of the pipeline, which will be to make the prediction from this saved model in this second bucket. All right, so that's exactly what we're going to do. So now you're going to do it a bit with me. I'm going to ask you a question. According to you, what is the only thing we need to do? Well, actually, two only things. What are the only two things we need to do in order to get these predictions? By the way, in your folder, in the code folder, you have a wine. in this JSON file, you will find exactly one wine, one red wine, all right? That's your red wine. It has those features, and now we're going to predict the quality of this wine. So according to you, what is exactly the two things we have to do in order to get the predicted wine quality for that specific wine in your JSON file? Reza, yes, back on track. Awesome. We should feed the Lambda function using the other handler with the JSON file. Exactly right. Well, I don't know if it's what you meant, but yeah, we're with the JSON file. So that's exactly right. We need to change the other handler, well, the handler with the other one, and we need to provide the JSON file as an event, right? Because this time there is an event, there is some inputs to enter. So that's exactly correct. That's what we're going to do. Let's do this. All right, so let's do the first thing first. We're going to change the Lambda handler. So this time, we're not going to call the train evaluate save function. We're going to call, of course, the predict wine quality function in order to get that prediction. By the way, we didn't check what we got for the mean absolute error. Where's the execution result here? Okay, I'm gonna in execution result, sorry, I forgot to show you that there was the mean absolute error, which was pretty small. Normally, I don't know if any one of you noticed it. Well, I can show you right away. I'm going to remove this. I'm going to delete this model. I'm gonna create a new one. I'm just gonna show you the execution, the mean absolute error. All right. So I'm gonna run the code again. All right. And I'm going to show you the mean absolute error, which is pretty small. Remember that the ratings go from 1 to 10, and with a 0.1 float. So you're going to see that it's pretty small. All right, so now a new random forest model is being trained, random forest number 25. And in the function log, you will see the mean absolute error here of 0.394, which is pretty good, right? The mean absolute error is like the average of the differences in absolute value of between the predicted wine rating and the real wine rating. And so on average, we have an error of 0.394, which is pretty good considering that the scale of the ratings of the wine go from 0 to 10. So that's pretty good. So we have a pretty good model. And so now we're gonna make the prediction. So back to what I was saying, the two things we have to do indeed is to change first the handler, which this time is the predict wine quality function. So I'm copying it, and below I'm gonna edit the handler here, and I'm gonna replace that train evaluate save handler we had before to train, evaluate, and save the model by this new handler to predict the wine quality, all right, which is the predict wine quality function. So now it is only the predict wine quality function that will be called when we run the Lambda function. All right, we still have our scikit-learn layer. We click save. And now we have the right Lambda handler. Okay, we have the right Lambda handler. Here it is. Lambda function, which is the name of the Python file, all good. And then predict wine quality handler, which is the name of the function inside our Lambda function file that will be called when we run the Lambda function. Great. So that was the first thing we had to do. And now the second thing is in the test, we have to configure the event. And remember that AWS Lambda is a event-driven compute service. And here we have to indeed provide an event, which is actually the inputs of the wine features, all right, which are exactly right here. So we're going to copy all this. We're going to paste that here. And here, make sure to enter your model name. So it could be an environment variable here, but it will be quicker to do it this way. Enter your model name here. You just have to go into your ML pipeline model S3 bucket. You take your model name, random forest model with the generated number that was, well, the random number that was generated. You copy it, and then here you just enter your model name, random forest model 25 for me, and that's it. And so basically, we're going to predict the quality of a red wine that has a fixed acidity of 6.0, volatile acidity of 0.3, citric acid of 0, the residual sugar of 2.0, etc. All right, and this is the alcohol level, 10%, quite neutral, pH of 6.5, the density. So you see, if any of you is an expert in wine, maybe we'll try to increase the rating of that wine. All right, so that's the event that you have to configure with the input features of the wine, and that's it. That's all you need to do. Now we're ready to run that part of the pipeline to make the prediction of that red wine, which is the inference, indeed. All right, all good for everyone? So error is 4%. Does this mean an error from -2 to +2? Yes, yes. That means this. It's not 4%. It's mean absolute value. Yeah, it is 4% actually, because it's 0.04 divided by 10, right? You got 0.4, right? It is 4%. Yes. Okay. So yes, that's exactly that. From -2% to +2%. Diane, sorry, I didn't see your question. The error you mentioned is an indication of how well the test set work on the trained model. It's an indication of how well the trained model work on the test set. Yes. I think you all got more or less around 4%, right? Okay. So let's now test it. Let's get our prediction. So just make sure you have the right Lambda handler, predict wine quality, and just make sure you have entered the features of the wine in this JSON event JSON. All right, that's all you need to do. And of course, replace the name of the model here. All good for everyone? Is everybody ready to deploy this? Let's do this. 3, 2, 1, go. Action started. Now it's going to take just a few seconds. It's going to be very fast because we don't have to train a new model. So it's going to take, there you go. And I get a wine that has a 5.3 rating for the wine quality. Here it is. That's the response here. What did you get? So because there is an absolute error, because there is a mean, because there is a mean absolute error of 0.4, then you should get different things. Yes, Jordan, you got 5.6. Good. This is normal. Mediocre wine, yes. But did you notice how wine ratings are very tough? I mean, I don't know if you know the Vivino app, but it's very, very hard to find a wine that has high ratings, you know? Most of the wines, for example, that you scan at the supermarket have, average ratings. So it's actually quite rare. So I don't know if I would drink a 5.3 red wine, but at least this is in the good side, you know, on the good side. And do we have any experts in, can you ever find a 9 or 10? Do these wines exist? I suppose they exist, but they're very, very few, like maybe, less than 1,000 bottles for sure. Camus? Oh, okay, I'll check it out. William, is any of you an expert in wine? Do you know how we could get a higher wine rating by, changing just changing a bit the features here? Maybe if we reduce the alcohol or increase it, I don't know. I'm not sure at all. Maybe if we increase it a bit, 11, maybe that will make the wine better. Maybe if we put a more neutral pH, let's, for example, try 7.0. I don't know. I drank wine before for sure, but I don't know about these features like an expert, you know. Density. So I guess this is a fine density, right? Free sulfur dioxide. I don't know. I don't want to change that. I don't want to do nonsense. Residual sugar. Okay. So yeah, you have some sweet wine, some less sweet wine. I think the very good wines are not too sweet, right? They're a bit more dry. So maybe we could decrease this a bit. We could, for example, do 1.8. I'm not sure. You know, I'm really not sure of what I'm doing here. Volatile acidity, fixed acidity. Maybe we could reduce a bit the acidity. I don't know. I have no idea again. But let's try this. I'm just trying to make the wine better. You know. So let's see. So that's my new event, Jason. I can share it with you if you want, but maybe this will lead us to a terrible wine. And if you find a better wine than me, let me know. Now it is more acid. Reza, you're saying that my wine is more acid because I reduced the acidity, fixed acidity. Okay. Let's try this, and then I'm sure someone of you will find a better wine than mine. So I'm going to go back to the code, and I'm going to test it again. And let's see if I manage to beat my wine. 5.4, yes, I at least improved it a bit. I went from 5.3 to 5.4, but since there is a mean absolute error of 0.4, it's not really sure that I improved the wine. Did you manage to get a 6 or a 7 wine? That would be amazing, right? Increase the acidity number as it will be more basic. Okay, I'm going to increase the acidity number. I'm going to follow your advice. I'm going to increase the fixed acidity to 8. It was at 6.5, and I'm gonna put 7.5. I have no idea what I'm doing, but let's try. Okay, so now I increase the acidity. I'm gonna see if I get a better wine. You know, let's imagine we are a wine producer and we are working on making our wines better, and we have to tweak the features in order to get a better wine. So I'm still getting 5.4. All right, no, I'm just playing here. Of course, this is not essential to this lab. But if any of you got a better wine, let me know, and please share the JSON file containing the input features. All right, are we all ready to move on to the next step? Now is the time we make this pipeline automated. Do you want to move on to the next step, or to continue playing with the wines and try to get a better one? Yes, please. Yes, please. Go ahead, please. Next steps, you mean? Let's move on. Okay. Yeah, me too. I really want to get at least a six wine. That would be great. Next step. Okay, so let's do this. So now the next step. Okay, so we did all this. That's great. But we did not automate the pipeline yet. We did not make the pipeline automated yet. And we did this. So now is the time to make our automated pipeline. So what do I mean by automated pipeline? I mean that we're going to kind of do real-time analytics, meaning as the data comes in, as the data is updated, well, the model is going to retrain automatically to provide a new model from which we will make new and better predictions, all right? Because the more data we have, the more likely it is to make better predictions, all right? So that's exactly what we're going to do. And how we're going to do that? Well, thanks to Lambda triggers. As you can see, these are some new artifacts that you can implement in your Lambda function. You can add a trigger so that when this trigger happens, when the Lambda function is triggered, well, automatically it will run this code, the Lambda function code with a specific Lambda handler that we'll choose, of course. But first, let's add this trigger. So the trigger that we want to add is that anytime the data is updated in S3, well, the model is going to retrain automatically and therefore provide a new model, all right? So here in trigger configuration, what do we have to do? We simply have to select a source, which will be, of course, S3, right? Because the data is anyway going to be updated in S3. So here we choose S3. And here we're going to enter, of course, the bucket that contains our data, in which the data will be updated, or modified. All right, so we choose this one, ML pipeline data, this one. And now, very important, what is the event type? What is the event type that will trigger the Lambda function? All right, so let's see the different event types we have for S3. We have all object create events, put, post, copy, multi-part upload completed. Then we have delete events of objects. So delete all object delete events, permanently deleted, delete mark created. Restore from Glacier initiated, restore from Glacier completed, object in RS lost. So these are all the different triggers that we can have so far at the time I'm speaking within AWS Lambda for S3. So according to you, which triggers should we select here. Oh, you got a better wine, William? Which one did you get? Diane, you say put. I would say, Diane, you are exactly correct. Yeah. I was gonna keep all objects create events, but actually we can only do it with put, because the way we're gonna update the data set is by providing a new data set into S3. So yeah, we can just simply choose put. That's completely fine. The other ones are not really essential to the way we want this pipeline automated. That's exactly correct. Yes, put. So yeah, we're gonna follow Diane's suggestion and we're gonna select put, indeed. So put from S3. Here we don't need to enter any prefix, that's fine. We don't need to enter any suffix. Here we just have to acknowledge that using the same S3 bucket for both input and output is not recommended, and that this configuration can cause recursive invocations, increase Lambda usage, and increase cost. That's completely fine. And then we're gonna click add. All right, make sure to choose the right bucket, ML pipeline data. Okay, great. So that's, what we did here. Exactly implement this automated pipeline. That's it. That's all we needed to do to automate all this part of the pipeline. This whole part of the pipeline, we automated it by simply creating this S3 trigger with the put event, the put trigger. That's it. Meaning that each time we're going to update our data by providing into our S3 bucket, the one of the data, a new CSV file with new training data, well, automatically this will run. All right. So let me show you this right away. Let's experiment this. All right. So we have our trigger. Now back into the code. What do we absolutely need to do now in order to, make that final pipeline? What do we need to do? What is left to do here to make that final automated pipeline? We just need to do one thing. Let's not forget this. It's very important. Exactly, William. We need to update the handler because right now the handler is indeed our predict wine quality function. But now we just want to automate the training of the function each time the data is updated. And therefore, we're going to take again our train, evaluate, save function from our Lambda function, our train, evaluate, save Python function from our Lambda function. We click edit here, we change the handler, we replace the predict wine quality handler by train, evaluate, save handler. We click save, and now we have our final automated pipeline. It is a machine learning, it is an automated machine learning pipeline that will automatically train a machine learning model, which is a random forest model, each time the data is updated into our S3 bucket, the data S3 bucket. Let me show this to you. It's absolutely awesome, you'll see. So we don't have to change anything to code. We're all good here. So what I'm going to do now, oh yes, actually we need to, no, we don't need to do anything. All good here. We're all good in the code. So what we're going to do now is very simply take our data set. Well, actually it's right here, no? Yes, take our data set. And just for fun, we're going to add 3 wines, okay? So I'm going to do that efficiently. I'm going to take this. I'm just going to increase everything by 1. I'm doing nonsense. I don't know. No, this might be a rate. So I'm going to increase by 1 here. All right. I'm just adding a wine here, you see, 3.7. I'm just changing a bit the number, 7, 19. Oops. 19, 43, 6. All right. 3.49, 0.67, 12, and I'm just going to change the rating. Of course, it's going to be a lower rating, so I'm going to put 5. Well, I'm just going to add 1 wine, okay, just to save time. All right, so I'm adding 1 wine. All right, so the training data was updated, the data set was updated. There is more training data now. Let's imagine that indeed more training data came into our data set. I'm going to paste it. All right, and now we have a different data set with more training data. And now in my S3 bucket, I'm going to go back to the ML pipeline data S3 bucket. I'm going to remove this. This is not part of the pipeline. Let's imagine that we have a data engineering team that managed to implement a system that automatically updates the data into S3 by deleting the previous data set and adding a new one. But of course, we're going to do that together manually. So let's delete the previous data, the data that we had. Permanently delete object. All right, and now let me show you something super cool. I'm going to upload our new data set with more training data. All right, live lab data here. I'm going to open it. I'm going to upload it, and as soon as I click the upload button, I'm going to directly go into my other bucket, the model bucket, and I'm going to refresh a couple times, and you will see that at some point we will see a new model appear in the bucket. Are you ready? 3, 2, 1, go. Upload. All right, so it's uploading. All right, uploaded, close. Now I'm going to go back to my other bucket, the ML pipeline model bucket. It has only one model, the one we had before. I'm going to refresh a couple times, and you will see that at some point I will see a new random forest model that was automatically retrained, and therefore a new model in the ML pipeline model bucket. There we go, new model. And I didn't click any test button, right? I didn't click any test button here or any test button here, right? I just added a new CSV file. I just updated my CSV file of the data set, and automatically I got that new model, random forest model 32, obtained right now. It is indeed 11:04 p.m. for me. Did you get the same thing? What is going to happen with the prediction part? The handler has changed to train evaluate. Yes, so Diane, as you can see, the prediction part is not part of the automated pipeline, because indeed it's a bit hard to automate this part as well, because anyway, in order to make a prediction, we need to enter some values. So we're only automating part of the pipeline where we train the model as the data comes in. As new data comes in, as the data is updated, well, we retrain the model to get a new model with that new training data. All right. But this, anyway, we need to provide an event. We need to provide some wine features in order to predict the quality of a specific wine. So it shouldn't be part of the automation. The automation should only be for the training of the model. Each time the data comes in, each time new data comes in. And then we'll do that final part. All right? I hope that answers your question. Dietrich, you're saying, I'd rather create a new model after a number of new wines. Yes, of course, I completely agree. But it's just for the lab, just for educational purposes. I just wanted to create one wine so that it doesn't take too much time. But of course, in real life, you would retrain the model each time you get 10 or 50 or 100 new wines, and that you would need to tell to the data engineering team updating the data and uploading into S3, with maybe an automated other data pipeline. So that you only retrain the model after getting 10, 50, or 100 new wines. I completely agree, but I just wanted to update with one wine to show, to simulate that the training data has changed in order to illustrate this. Okay, so did you all get the same thing? Did it work for you? Yes, the automation works. Perfect. Thank you, Jordan. Yes, William, it worked. Perfect. Super cool. Super cool. Great. So now let me know if you're ready to move on to the last part of the pipeline, which is to send invocation records to SNS. And why did I use this? It's just to, really make you a pro of Lambda and show you all the different features of Lambda. This is just this. I just wanted to show you this, how this works. It's pretty cool. It basically allows you to get notifications of when your Lambda function is being triggered, and therefore when your machine learning model is retrained. So then you will, more or less know everything about Lambda, all the different features. Then you have some more things. You can deploy your machine learning pipeline to Lambda Edge, but we're not going to do this today. I just wanted to show you the full pipeline here. And so, are you ready to move on to the next step? Then what I'm trying to say is that if now I need to do a new prediction, will I need to change the handler? Yes, you do need to change the handler, yes. You do need to change the handler. If you don't want to have to change the handler, a solution to that is to create two different Lambda functions. One that contains only the train, evaluate, save function with the different functions before, to pre-process the data. And another Lambda function that contains only the predict one quality function. That's, yes, exactly. That's the solution to not have to change the handler. Correct. Yeah. But why do you need to change the handler? Nafsika, we need to change the handler if now we want to do some prediction. Because now I just wanted to explain how to automate the pipeline. So how to automate this, in which indeed the inference is not part of. All right. The inference is not part of that automation here. And therefore, if now with this new trained model that was automatically retrained and resaved into S3, well, if we want to do some inference, if we want to make a new prediction with that new model, then we would need to change the Lambda handler indeed. Okay, get it? Okay, cool. Are we ready to move on to the final step? This is the final step of this lab for this machine learning pipeline. We're going to implement the destination in order to receive invocation records each time our Lambda function is either triggered or each time it is run, each time it is executed, if we press the test button. So if you're ready to move on to the next step, please say yes in the chat. Let's do it. Great. I'm super glad you're all here. This is a long lab and you're still here. That's absolutely amazing. I really love it. This is exactly how I want those labs to be. I want those labs so that all of us build what we want to build in the lab. So let's do this. All right, Lambda, let's go back to Lambda. You will see that it's super simple. So we're going to add a destination here to get the invocation records. As you can see, we configure a destination to receive invocation records. All right, so here we're going to choose asynchronous invocation because, our Lambda function is going to be triggered punctually, from time to time. We would choose this if we had some streaming data, that would come on a regular basis. But here we're just going to, from time to time, punctually invoke our function, and therefore we're just going to choose asynchronous invocation. Condition, let's get the records on success, basically we want to get the notification each time our Lambda function is triggered so that we can know when our machine learning model is being retrained, all right? Then how do you want to be notified? Do you want to be notified by email? Do you want to be notified in an SQSQ or in a Lambda function? I suggest we choose email, right? Thanks to SNS. So we're going to choose SNS topic and then destination ARN. So there you go. We need to create a new SNS topic. So let's do that quickly. We're gonna go to service here. Well, actually in search, SNS. All right, and make sure to open this in a new tab. Click right, open in a new tab, and let's create a new topic. All right. Welcome to Amazon SNS. Let's create a new topic. Create topic. We're going to choose a standard topic. Then, let's call it again ML pipeline. Well, I'm going to take actually the thing. There you go. ML pipeline. All right. And here I'm going to replace that by SNS. All right. Or topic. ML pipeline topic with the same reference number. And that's it. You can just create the topic. Perfect. Then we're going to create a subscription. Here, we're going to choose, of course, email, unless you want to be notified somewhere else. But the simpler is email. Here, we're going to enter an endpoint. So let me actually, which email address did I get for that? I think it's CloudWolf. You can enter any email anyway, but I think I call this CloudWolf Live Labs at gmail.com. Let me actually try to connect to that Gmail. Gmail. I'm going to quickly sign in to this. Yes, there it is. So that's the one. I'm going to quickly sign into this email so that I can show you that indeed I'm getting the notification. So what is the password I entered for this again? All right, I'm in. Perfect. Not now. Great. I'm going to put that here. Excellent. Voila. All right, so let me just mark it as read because, wait, where is it? Mark as read. Okay, so that we can see the new one, more easily. Okay, so great. Let me just make sure I got the right one here. Perfect. So you enter the email where you want to be notified here. Here in protocol, you choose email. And then you click create subscription. Subscription to ML pipeline topic created successfully. Perfect. Now we need to confirm the subscription. There you go. New email received, subscription confirmation. You click in the email, confirm subscription. Subscription confirmed, perfect. So now we're subscribed and we can get the notifications each time the Lambda function is triggered or each time we run the Lambda function. All right, so here I can refresh and I will find my ML pipeline topic. Perfect. ML pipeline topic with the ARN. I don't know why I get this, but this should be fine. I'm going to try to save. And does it work? And on success, condition is on success. We will be notified on success, meaning each time the Lambda function is triggered, meaning each time we update the data. And there you go, it worked. Your changes have been saved. Now I'm going to help you. Did it all work for you? I think so, Jordan. Okay. Bravo. Merci, Alain. Okay, good to go. Okay, good. Okay, Jordan, you let me know if you have any issue, right? Let's see. Let's test it out anyway. Let's test it out. All right. So how do you want to test it out? We have two ways of testing it out, but of course I prefer the second way, which is of course by triggering, right? By using a trigger, meaning by updating our data. So let me, I don't know, we don't have to do this, but I'm just doing it for the purpose of simulation. Where is the data? It's right here. Okay. I'm going to update the data again. I'm going to just add one more one. I'm going to just change one value to make it faster. There you go. Up. Dataset changed. The data engineering team just updated the dataset with new training data. Of course, let's imagine that they added 50 more wines or 100 more wines instead of just one wine. That's just to make it simpler. And now let's re-upload the dataset, that new dataset with more training data into S3. And let's see if not only we get a new random forest model, but also if we get that invocation record sent as a notification to our email. So let's go back to the bucket. Let's go to ML pipeline data bucket. Let's delete this. All right. So this, we do it manually, right? Just to simulate the data integration part of the automated pipeline. Permanently delete objects. All right, and so here we go. Now let's update the data by uploading that new version of the dataset containing more training data. And let's imagine that 50 more wines were added. Wine quality red, open. All right, it's let's click upload, scroll down, upload. It's uploading. Close. Now let's quickly go first to the ML pipeline model to see if we have a new model. I'm going to refresh. We have model 25 and 32 for now, for me. And soon, once the new random forest model is trained, it will be saved in this new random ML pipeline model bucket. And there you go. That's my new random forest model number 56. And now let's have a look at our email. Did we get a notification? And yes, we did. AWS notification message with the invocation record. That's exactly the invocation record with the different informations. especially your new model that was just trained, the random forest model number 56. Did it all work for you? Yes, let's test, Jordan. Is the test successful? Yes, awesome. Fantastic. Fantastic, because basically you completed successfully the lab. Super cool. Yes, I agree. This is really super cool. I really love Lambda. It's, after discovering all this, I was feeling like Tony Stark in the Lambda lab. Not yet in the AWS whole lab, but at least in Lambda. Yes, so sweet. William, you got it too. Awesome. Congratulations. Reza, did you get the same thing? Did it work for you as well? Ray, how about you, Ray? And Dietrich? And Nafsika, don't worry, I will help you at the end. I will debug the problem you had, troubleshoot it, and you will also get those final results. Don't worry, no worries at all. Anil Kumar, you're saying this is awesome, so it worked for you. You will definitely, yes, if you want, we can troubleshoot this together in this live lab, and I will just edit the recording, no problem. Ray, you're just following. Okay, but you understood, yeah, right? You understood how we did this. Chuck Woody, it worked for you. Thank you. Perfect. Okay, super. So it worked for everyone. Therefore, huge congratulations. You fully implemented the final machine learning pipeline with that automation part that automatically trains the model each time the data is updated. As the data comes in, it's almost like we implemented some real-time analytics application. So huge congratulations to that. And now please stay with me. We're going to, of course, do the final cleanup because it's very important. I don't want you to get charged by surprise. All right, Priyanka, great. Thanks, Adlai. Most welcome. I'm glad it worked for you as well. Okay, so now please stay with me. But before we do the cleanup, do we have any question? If not, you can enter a cleanup in the chat and I will execute. Cleanup. Okay, Chakudi says cleanup. Cleanup. All right, let's do this. Let's do the cleanup. No question. Perfect. So let's do the cleanup. All right, so first, let's, what do we clean up first? Let's clean up everything in Lambda. So it's very simple, very, very simple. We're just going to go to functions here. We're going to select our ML pipeline Lambda function. We're going to click actions and delete. And here we enter delete and bye-bye Lambda function. Now we no longer have a Lambda function, but of course, you know very well how to re-implement it. All right, so we're all good with Lambda. We can close this, right? Lambda 0, Lambda function, all is good. We can close this. Now, let's clean up S3. So let's go back to the buckets, the bucket level. Let's first empty the ML pipeline data bucket. We enter here permanently delete, empty, exit. Now we reselect it and we click delete. This time we have to enter the name of the bucket. We enter the name of the bucket here and we click delete bucket. Then we're going to empty our model bucket. I have 3 models inside, so I definitely need to empty it first. I don't know how many models you got in total. Empty, permanently delete, empty, and exit. And now we can delete the ML pipeline model bucket by clicking delete here, then entering the name of the S3 bucket, and delete the bucket. All right, all good for S3. All clear in S3. We can close S3. Now let's delete the roles. It's not compulsory. You will never get charged for a role, but it's better to do a full cleanup. So there we go. Let's select our S3 full access role. Let's click delete. Let's enter the S3 full access. And let's click delete. And role deleted. Perfect. All good here. We don't have any custom managed policies. I think we're all good here. I see, yes, we do have some custom managed. Yes, some custom. No, but that's from before, sorry. Let me just delete that quickly. All right. This was from a previous lab. I forgot to delete. All right. And this one as well. All right. Okay, so normally you should have absolutely no custom managed policies. All right. Yeah. Ah, yes, you should have one actually. You should have a policy for AWS Lambda SNS topic destination. Okay, so let's clean this, delete. It just appeared for me for some reason. Deleting policy. Policy deleted. So now it should be all good. Yeah, no custom managed policy, all good. So we're all good in IAM. We can close IAM. And finally, let's delete our topic, not only our subscription, but also our topic, but I think we can directly delete the topic and automatically the subscription will be deleted, but I'm not even sure. Let's test. ML pipeline topic, let's click delete. Delete me, delete. And I think the subscription might still be there. Let's check. Okay, so we don't have any more topic. Now subscriptions, and see, the subscription is still here, even though we deleted the topic, right? This is the same one, ML pipeline, see? So yeah, let's delete the subscription as well. It makes absolutely no sense to keep that subscription because anyway, the Lambda function is gone. So let's click delete, delete, and cleanup done. And that brings us to the end of this live lab number 7. Congratulations, it was a big application that we built, right? This whole machine learning pipeline. So congratulations for having reached the end of this lab and successfully built this pipeline. Any questions before we wrap up? No, thanks again, Adna. Okay, super, most welcome. Another success, yes. Another success for all of you, right? Because you were super active during this lab. We started at 20 participants, and almost until the end, we were still at 16, I think, and now 14. So that means you all successfully built this machine learning pipeline with that automation part. Congratulations. Thank you very much. You had to step away a couple times. This will be posted, correct? I had to step away a couple times. Ah, you mean you had to step away a couple times? This will be posted. Yes, absolutely. The recording. Yes, you had to step away a couple times. See, yeah, absolutely no worries. I will just edit the lab a bit, and then I will post it, and you will be notified, especially with the Content Weekly updates. Dietrich, thank you so much for saying many thanks. Live labs are very helpful. Yes, that's the purpose of it. It's to all make you feel like Tony Stark. AWS service by AWS service. It's hard to be like Tony Stark in the cloud lab yet, but at least we're going to do it AWS service by AWS service. And I can tell you that now we almost touched all the functionalities of Lambda. We built a machine learning pipeline, and we'll see that out there online on YouTube, there's no tutorial or lab that does all the things we did. And actually, I checked how they import the scikit-learn libraries and the NumPy libraries, and they do that with some commands. It's very complex, complicated. So I think we did the best solution. Thank you, Jordan. Thank you so much for saying this. You're very welcome. I'm the Batman, the Wolfman. Yes. Let's all become the Wolfman. And thank you so much for being here. You were all super great. You participated to this lab. You built this machine learning pipeline. So that was awesome. Thank you so much. I really enjoyed this. And yeah, thank you so much for all this praising. That's very nice. That's very nice. I am super excited about these labs, and the purpose is to really, for all of us to really become really good at it. Really Tony Stark level in the cloud lab. All right, so see you next time. Now I'm gonna stay with Nafsika, and also I don't remember who exactly, but someone else had some issues. So I'm gonna stay with whoever wants to stay to troubleshoot the issues, and I'll see you in the next labs, the other ones. Thank you very much. and see you very soon. And enjoy the cloud. Bye-bye. All right, Nafsika, let's troubleshoot your error.
Yes. So,
So, you know what? You will share your screen.
the
It will be
backend.
easier.
Okay.
Ray, you want to stay? Okay, sure. Stay, Ray. Maybe you can see some more stuff.
Okay. Let me see how I can share. I'm not used to this environment. Wait. How do you share?
Anil, you're staying also perfect. Yeah. Anyone who wants to stay, feel absolutely free to stay. I'm just going to troubleshoot some issues here.
Hadlin, how do you share in this environment?
Okay, so
toggle screen sharing. Okay.
Exactly.
Next window, live lab. No, not that. Not that. Wait.
You can either share your whole entire screen or some tabs. Yes.
Yeah, just a moment. Select Windows. Maybe screen or window. Maybe that's better.
Yeah, screen is better.
No.
Yeah. Unless you don't want to show some other stuff you have, but
No. Okay. But it says not now. Then
not
setting
now.
it Lambda. Okay, I will share this. And
Yes,
then
got it. Perfect.
Yeah. So can you see
Exactly.
this now?
Yes, I can see your screen.
Good. So this is what I have for the S3 bucket name.
Yeah. For the model. Yeah.
For the model, yes. So this is for the data, the first one, and this is for the model.
Model. Correct. Okay.
Okay, and
Then show me your environment variables.
Okay.
Yeah, indeed, you got some issues here. Yeah. Okay.
Yes, you see. So let me show you the environment configuration. These are the ones.
Yeah. Very good. Okay.
I did copy paste. That's why I don't get.
Yeah. It seems to be correct. So this is quite strange. Click edit.
Yeah.
Okay. Click on key. I just want to see if there is not some hidden space or something like that. Click
Here?
key on. Yeah, here this is fine. Okay, and the other one key. This should be fine. Okay, and do the same for the values, please.
Yeah. Oh yes, maybe there's something at the end.
Yeah, maybe there's a space or I don't know.
Okay.
No, this is fine.
This is fine.
Okay,
too.
so this should be fine. Okay, all right. If any of you, Anil or Ray or Vikas or Rodney, who's still here, see any issue, feel free to help, of course. Okay, so now let's go to your code. Let's have a look at your code. Lambda function.
Okay, so that test?
Okay. So you didn't change anything in the code, right?
No, I didn't touch.
Okay. So scroll down, please. I mean, below the code. I'm just going to check the handlers.
Oh, okay. No, handler was.
It's below the code.
Yeah, here.
Okay, Lambda function, train, evaluate, save. Yeah, you got Python 3.8. You got the layer. It's all good. It seems to be all good. Okay, so try to test the function again. Invoke it again. And if it doesn't work, we will simply redo it again.
So test here?
Yes. Yeah.
Yeah, maybe I didn't save maybe I didn't save the name. Maybe I did it now, but previously.
Yeah.
Let's see. It's about 27 seconds.
Yeah.
It should show something.
Oh, we didn't check the event.
Yeah, but I can show you now.
Yeah.
Wait, just now. Yeah, you see, it's
Okay,
strange.
model
The test
bucket
I will
name.
show you.
Okay,
You see,
please go.
it's empty.
The event is fine. Okay, go back to the code and check the model bucket name environment variables. Go to the Lambda function.
Yes.
Model bucket name. Yeah, it's fine, right? Model bucket name.
Yeah.
Okay, I'm really not sure what the problem could be, so I think the best way to solve this is to completely redo from your
Yes.
screen the steps. It's fast anyway.
Yeah, I can see that.
Okay, so below a window, sorry, I was not looking at the chat, so I think Vikas and Ray spotted a mistake. Below a window in the middle, between leave and the hand, we can see it too. Oh, below a window in the middle, between leave and the
About to
hand.
share, I think.
Huh?
They were just talking about how to share. That's okay.
Okay. Sorry. All right. So let's do this. Let's redo it, Napsika. So yeah. Go back to Lambda and delete your function. So you go to functions. Yes.
Yeah. Yes, and then my Lambda function. Everything I delete.
Delete both. Yeah, delete both to make sure. Just copy the name of your function so that you don't have to retype it. ML pipeline function. Just copy this. Yeah. Good. Yeah. Delete.
Delete?
Okay. Yes.
Actually, you know what? My Lambda function, I will leave it because I did it during the course.
Yeah, the course. Okay.
Yeah.
Gotcha.
So delete. Yeah. Okay.
All right. Great. Now create a new function. On the right.
Create function. Oh, it was already on the right. Okay. Yeah. So.
All right. Paste the name. Great.
Yeah.
Now runtime. You choose Python 3.8.
Yeah.
Okay.
That's
Change
it?
default execution. No. Change default execution role.
Oh yes. Yeah.
Use an existing role.
Okay.
Yes.
Function.
Create function. All right. Okay. Now let's start by adding the layer. So you click layers. Maybe you got a wrong layer. You know, I don't know. Let's see which layer you got. Okay. So then you click add a layer at the bottom right.
Yes.
All right. Now specify an ARN. Great. All right.
And this now.
I'll provide the link to you again.
I have it. Where did I put it?
Are you in US East 1?
Yes.
Okay, good. So I provided the ARN to you in the chat. Yes, you are in US East 1.
Yes.
Perfect.
Yeah.
So you can just copy the ARN directly. No, not this one. The one just above. This is the link of the GitHub.
Sorry. Yeah. Okay.
Thank you, Vikas. Though. Thank you. So yeah, you copy the ARN. You paste it here. Perfect. You can click verify if you want. Yeah. Compatible
if nothing
runtime.
happens, it means it's okay.
Yeah. It's okay. Yeah.
Click add.
Yes. Okay, great. Now you have your Lambda layer. Great. Super. Now let's paste the code inside. So open the Python file in the text editor, copy the whole code.
This?
I mean your Python code. You know the Python code in your folder.
It's this one.
I can't see your screen now. I stayed at the lump.
Oh, okay. When it's your code, right?
Yes, it's my code.
Yes, that's what I'm doing. Wait. So control Let's see. And then I go to Lambda. Oh, no, this function. Okay. Code. Can you see my screen now?
Yes, yes, you're in
Okay.
the code editor. So remove all this. Great, perfect, excellent. Now deploy. Don't change anything, just deploy. Yeah, perfect.
No.
Okay, now we're gonna change the Lambda handler. So copy, train,
Yes.
evaluate, save.
Okay.
Yeah, here. No, a bit below. Yes. Here, at the bottom, train, evaluate, save. Copy this. Yeah, very good. Okay, now scroll down below the code.
Oh, yes.
Click edit.
Here.
Yes, but you have to click edit.
Edit. Yeah, yes, sir. Yeah.
Okay, so you keep lambda function dot and you replace lambda handler by yes, but you remove lambda handler and remove the L. You remove the L.
Yeah.
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 Okay, so I think this is good now. Train evaluate save lambda function dot train evaluate save. Yeah, that's good. So you scroll down and you click save.
Save.
Yeah, perfect. All right. Good. Now we're going to go into configuration. Yeah. First, we're going to go to general configuration. And we're going to increase the timeout to 59 seconds.
Oh, yes. Okay.
All right, save.
Okay.
Perfect. Then we're going to go to environment variables. We're going to go to environment variables. I'm going to send it to environment variables.
So there I go to S3.
Okay, so just for the first one. So I'm pasting you the key of the first environment variable, which is this one, data S3 URL. Great. You paste that as the key.
Yeah.
All right. Then you go back to S3. You go into your ML pipeline data bucket. No, not this one.
Oh, yes. It was the file, yeah.
Exactly.
Like this. And
You
then
get the
you
URL.
say
Okay, you
the
select it.
URL.
Yeah, you can go inside.
And it's this one.
Exactly. Object URL.
Okay. And then
Okay,
this.
good.
And then
Value.
this.
Okay.
And then add.
Perfect. Yes. I'm going to give you the other one, which is model bucket name. All right. Done. So you paste it, you copy this. You paste it inside the environment variables for the second one, the key. Great. Now you go back to S3. You go back to your buckets. And you copy ML pipeline model 1, 2, 3, 4, 5. No worries. ML pipeline model 1, 2, 3, 4, 5. Copy. Perfect.
Sometimes the brain is bugging. And then it comes back to normal.
Yeah.
So save.
Save, yes. Perfect. All right. Now let's test it out. We just have to, test. Go to test.
Oh, yes, we have to
Yeah.
remove all
You
this.
provide an empty event. Perfect.
Okay. And then we test.
Okay. And now let's see if this works. And if this works, I have no idea what was the issue before, but let's test. Yes. All right, let's see. Let's see. If it doesn't work, it's really strange.
Yeah.
10 seconds, 10 seconds. So now, supposedly, your random forest model is being trained.
It's about 30 seconds. If it doesn't work, I will listen again to the record. Oh,
Yes,
it's
it worked.
working.
Congratulations.
Oh, fantastic. Fantastic.
And you
Oh,
got
fantastic.
a low mean absolute error. Yeah.
Ah, let me see the error. What is it?
No, there's no error.
0.3. So mean absolute error.
Yeah,
Oh,
mean
fantastic.
absolute error.
I'm very happy. Yeah, I'm very,
Nice.
very happy. Thanks, Hadley. This is
Yeah.
really good. Okay. Okay, I listen to the rest.
Perfect.
This is so exciting. It's so exciting, this stuff.
Yes. Very exciting, huh? And yes, Vikas,
Yeah.
it's good that you stayed. It was a quick revision. You know, it's like we did a recap for those who stayed. That's also good. So, you know, Nafsika, your issue with the code was benefit to everyone who stayed.
Yeah.
Super great. Any other question before we wrap up?
No question, just a big thank you. And do another lab.
Absolutely. I will do, I will do one lab per month. That's the minimum. But actually, Kira and I want to do more labs in CloudWolf, only they will be given by other experts. Okay, so I will always do one lab every month. Okay, no problem with that. But also there'll be other labs by other experts. So this is awesome. You'll get to build more applications.
Yeah, this is great.
Yes.
And tell me something,
You're welcome,
just by curiosity, Hadlin, when you automate the data that comes into the model, how do you automate that? You have to write.
Thanks to the triggers.
Oh, I see. No, I mean
you mean
the new data coming in.
Yes, you can do that.
You have to write a Python or what? A code, or how do you do that?
Yes, but it's not going to be done with Lambda. So you can do that with different data analytics service. You can do that with Redshift. You can also do that with Glue. I encourage you to check out the first lab that we did in CloudWolf. You were not in CloudWolf yet, but in the first lab, live lab number 1, we implemented an ETL process, extract, transform, load.
Yes.
The lab loads the data into Redshift, but you can totally load it too into S3. So that automation part of the data integration, you can do that with another service, either AWS Glue or other services that have integration with S3, like Redshift. What is also RDS? You can, have a database and automatically re-update it into S3 anytime you have more training data. So yes, but I did not integrate it as part of the machine learning pipeline because this is more a data integration pipeline. But
great.
Sure, if you watch Live Lab number 1 on ETL, then you will be able to add that automation on the data integration because it's very easy. It's very easy to connect a database to S3 and update it automatically with automation tools. AWS is awesome. You can do anything you want.
Yeah. No, this is great. Really, thank you very much, Hadlin.
You're welcome. I'm super happy that it all worked out for everyone. Super happy that you were all ready to build this machinery pipeline. Okay, so in the chat, you're saying that you would like me to keep this revision part, right? You would not. You would like me to not cut it, not cut it at the editing, right? If you want, I can just keep the whole lab like that. I don't have to edit it if you want. If you prefer, I can keep it like that.
If you don't mind me giggling, Vikas.
Yeah, because I also have to respect what you don't want to keep.
Hadlin, you can keep it separate. It's 2 files. I mean, option the other one. No, when you're I mean, it's up to you.
No, I mean, if all of you don't mind having the original, without the cut, I'm super happy to keep the original.
Yeah, I just want to follow the other one, her problem. I mean, just add it in there.
Okay, sure.
I mean,
definitely.
I don't mind. Yeah, I don't
mind. Okay, cool. All right. So yeah, I'll keep that part anyway, for sure. I'll keep that part. So thank you so much for joining. Thank you so much for staying almost 3 hours, right? 2 hours and 47 minutes. That was a long lab. And congratulations again for building this machinery pipeline.
Thank you.
Bye, Hadley. Bye.
Bye. And my CloudWolves say bye to you as well.
Bye from me too.
Bye-bye.